Let's continue on with 5.1. We're going to multiply rational expressions. So if you have P, Q, R, and S are polynomials, and Q and S cannot be 0 because they're in the denominator. So if you're multiplying a rational expression P over Q times R over S, you just multiply the numerators together and you multiply the denominators together. So let's do some example problems. We can just multiply through with the numerator. Now, really we can think of this as one big fraction. So we can cancel any common factors in the numerator and denominator. You can think of it this way. 15 in the numerator divided by 5 in the denominator. 5 goes into 15 3 times. 8 goes into 16 twice. So as far as the numbers are concerned, we have 3 halves. What about the variables? We have x squared times x to the first. What do you do with variables when you're multiplying? You add them. We have y squared over y to the first. What do you do with exponents when you're dividing? You subtract. So we have 3 halves, x to the third, y to the first power, and we do not have to write the 1. Here's another example. We can think of this all as one big fraction. One problem we have here is we have these two trinomials on the left that I get the feeling maybe there's a common factor here more than what we don't see any common factors. So I think a good way to approach this would be to factor both of these trinomials on the left. So we have x squared minus 2x minus 15. Can you factor that? And we still have that x minus 4. We need an x and an x. What are the signs? What factors of 15 do we want to use? 5 and 3. Which one is negative? The larger one is negative because that will give you a negative 2x. Let's factor that denominator, that x squared minus 8x plus 16. And we have our x minus 5 over on the right. We need an x and an x. This is a special product. Minus 4, minus 4. So now we see lots of factors. Now that it's been factored, we see things that we can cancel. Cancel factors, not terms. Cancel these guys, cancel these guys. And our final answer is x plus 3 over x minus 4. And of course you know that's as far as you can go. You cannot cancel the x's because those are terms separated from the rest of the problem through addition and subtraction. Once again, let's take that approach of factoring everything so we can see what can be canceled. X squared plus x minus 12. What are the signs? What factors of 12 do you want to use? 3 and 4. Which one is positive? 4 has to be positive so that you end up with a positive x as our middle term. In the denominator, 4x squared y minus 12xy, that just has a common factor. We just need to factor out the common factor of 4x, y. What are you left with? X minus 3. All right, and then 3x squared plus 12x, that also has a common factor of 3x. What are you left with? X plus 4. So let's look and see what factors we can cancel. I see x plus 4. I see x minus 3. 3 goes into 6, how many times? 2 times, and 2 goes into 4 twice. We have an x squared in the numerator, and if we take out this x and this x, multiply them together, we get x squared, so they can cancel with that x squared in the numerator. Gosh, we've canceled everything out of the numerator, but we have to put a 1 there to hold its place. Even if you get rid of everything, there's still a 1 there, a factor of 1 left. And our denominator, I see a 2 and a y. So that's our answer. Boy, that really simplified. I love it when you have a problem that looks pretty hideous, but then when you get through, it's all simplified. We're going to be dividing rational expressions now. And before we do that, I want to talk about division of fractions in general. If you have, for instance, 1/2 divided by 1/3, let's think of that as 1/2 over 1/3. So we have a compound fraction. I don't like 1/3 in the denominator. I want to multiply 1/3 by something so that I eliminate the fraction in the denominator. Well, the easiest thing to multiply 1/3 by is 3/1 by its reciprocal. That does really nice things to the denominator. The 3's cancel, you end up with a nice denominator of 1, and you have 3/2 in the numerator. So look what happened. You were dividing by 1/3, and that changed into multiplying by 3/1 because you had to multiply the denominator by the reciprocal. You also have to multiply the numerator by the reciprocal. So we kind of have a rule about dividing by fractions. We say, hey, if you're dividing by a fraction, just flip it and multiply. That will cause your denominator to cancel out even if it's a rational expression. So to divide by a rational expression, we're going to flip and multiply. Of course, we're dealing with rational expressions, so when we get through doing that, we better factor and simplify. So if we have P divided by Q divided by R over S, then that will give us P over Q times S over R. We flip the R over S and multiply. P times S over R times Q. First example, we're dividing by 14xy over 9d. Leave the first fraction as it is. Flip and multiply. We're looking for anything anywhere in the numerator to cancel with anything anywhere in the denominator. I see that these d's cancel. I'd like to get rid of them. 7 goes into 14 2 times. 3 goes into 9 3 times. 12 4 times. What about x squared over x? You're going to subtract. This has an understood exponent of 1, so you'll cancel out that x squared, and this 2 becomes a 1. It's understood that this is y to the first power, y to the second power in the numerator. You'll take the exponents and subtract 2 minus 1, and that also gives us an exponent of 1. What do we have left here? I see a 3, x to the first power, y to the first power. 2 times 4 is 8, and I see a c. Is that correct? I hope so. All right, we know we have to factor these guys, and you know, I'm lazy. So what I'm going to do is factor as I flip them, just so it won't take so long. So the numerator x squared minus 1, we can factor that. That's a special product. What is it? It's the difference of perfect squares. What about 10x plus 30? Can you factor that? Now we're multiplying this times the reciprocal of this second fraction, so we're going to factor it as we flip it. So 3x minus 3 factors into, and what does the numerator, or the 12x plus 36, which is our new numerator, common factor is? When you factor out the 12, you're left with x plus 3. So we factor and flip at the same time. So what can cancel? X minus 1 cancels, x plus 3 cancels, 3 goes into 12 4 times, and 2 goes into 4, 2 goes into 10, 5 times. So that leaves us with 2 times x plus 1 in the numerator over 5 in the denominator. That's it. Here's another division problem. So the first fraction can't be factored, leave it alone. The second fraction, we're going to flip it. Our 4a cubed b was in the denominator, now it's in the numerator. A squared minus b squared was in the numerator. We flip it down to the denominator. Can you factor it? A squared minus b, what is it? It's a difference of perfect squares. What can you cancel? Anything else? What about the a cubed in the numerator and the a in the denominator? This is understood to be an a to the first power, so we subtract the exponents. 3 minus 1 gives us 2. So we have a 4a squared in the numerator, a minus b in the denominator. So we've simplified that problem as much as we can, and we are finished with section 5.1. Go on to section 5.2 if you need to cover that.